Hello, good afternoon or good morning, everyone. My name is Jean-Daniel Roussel. I'm the president of the Java Card Forum, and it's my pleasure to welcome you to the second webinar in our series of 6 webinars on Java Card. Just before starting the presentation, a few words of the Java Card Forum. Java Card Forum is an industry association, and we are promoting Java Card and driving the evolution of Java Card. If we look to the latest release of Java Card, the 3.1 released by Oracle a little less than 2 years ago, this new release has features tailored for the IoT business segment. We know that in IoT, sometimes there is a constrained environment where the bandwidth or the cost of the equipment is limited, and the temptation is great to remove some features. So the presentation we have today will show that Java Card is a very useful features for most IoT devices, and that it's not probably a good idea to remove Java Card, and that can bring a lot of benefits that our presenter will show. Our presenter is Denis Praca from Thales. Denis Praca has over 30 years of experience in the security and telecom and smart card business. And in the last 20 years, he has been active in standardization in different standardization bodies like the GSMA, the ETSI, the SIM Alliance or Trusted Connectivity Alliance. He's vice chairing, by the way, the ETSI Smart Card platform, co-chairing this group. Before Denis starts the talk, let me inform you that you will be able to ask questions at the end of the presentation. We will open the mic so that you will be able to unmute a microphone and ask directly the questions. And if you prefer, you can also post your question in the chat window during the presentation, and they will be addressed at the end of the presentation. You can also focus directly on the presentation, and because we will send you PDF of the presentation tomorrow, and it will be available online. So just enjoy with the presentation. So without any more wait, I give the floor to Denis. Denis, you can start your webinar.
Hello, good afternoon, good morning, so wherever you are. So today I will talk about Java Card in the context of IoT devices. So mainly focused on the eUICC use cases, but also extended to other types of secure elements and devices that may or may not be 3GPP connected devices. Okay, so let's start with the problem statement, and that's the reason why I make this presentation today. So we have seen during a standardization discussion that there is a question about why supporting Java Card. So we know that IoT is massively deployed now, and it's driven by availability of very low-cost connected devices. If you look on Amazon, you will see connected devices like dog trackers, car trackers, and so on for 20 to 30 to 50 euros. So it starts to be really low cost, and I'm pretty sure that this cost will decrease in the future. And also with new 3GPP technologies like narrowband IoT, this cost will also decrease. So when you design this kind of device, and when you have the cost in mind, it could come to your mind that maybe I can remove Java Card support because it has a cost. It has a cost for the implementation. That's a bigger operating system, but it has also a license cost. So I will try to demonstrate in this presentation that it may not be a good idea, and that at the end, Java card may be a good way to save some cents or even some euros on the total cost of your device. So first of all, if you look at security requirements and regulation requirements, these requirements are increasing a lot. And if you look at certification or even simply testing, reusing libraries, reusing platforms that are already tested, already certified, will save you a lot of money during your development. And also using technology that provide natively some security features, like the Java Card virtual machine, which provide process isolation, will also save you a lot of time and effort in trying to secure, to make your product secure and compliant with the regulations. There's also another topic that we'll talk today is about the fact that you need to update your device because security implies updating because threats are evolving. So you need also to make evolution in your software. And Java Card can help you to update the device and can save you money in this update process because it's easy to update one Java Card object somewhere in the device rather than updating the full operating system. And also during the development, you will save a lot by using some expertise that is already available. And there are today a lot of experts in Java Card development that are trained from the beginning to design secure software. So if you use this expertise, you will save time and money in your development. Okay, so first let's have a look at some standards and regulation for which Java Card has, so it's even reference or has some interest when you design your product. Okay, first, the first one that's really the basis for a secure element, especially in connected devices, that's SCSCP. So SCSCP, that's the place where the eUICC is defined. So the eUICC is the platform, hardware and software platform, on which you will run secure applications, and the secure application can be defined, for example, by FreeGPP for the Usim and Isim application. And when you load these applications on the eUICC, at the end, you have what usually people call the SIM card. So a SIM card is the addition of the platform, the eUICC, and a secure application like the Usim. And if you look at UIC standards, there are two large specifications that defines Java Card APIs that will allow you to develop applications on this platform. So the biggest one is TS 102.241, which defines all the APIs for the platform, and 102.705, which is dealing with contactless applications. UIC specification also largely rely on global platform specification and especially global platform Java Card APIs. Global platform is defining APIs in order to manage all the security domains that are defined by them, all the secure channels also. And there are two types of applications which can use the eUICC as a platform. That's primary and secondary application. So primary application, that's an application a regular one that you can find on every computing platform. It's an application that the terminal will be able to directly use, instantiate, and use or send some command to an application, and the application will send answer to the terminal or to the remote entity which is connected to the terminal and to the eUICC through a secure channel. A secondary application is very specific to eUICC. That's what we call Toolkit Applications. So that's applications that make use of the terminal capabilities and in some way that are able to control some of the terminal features. So for example, call control, when you receive a call, the eUICC may be informed that of this incoming call even before the end user, and the eUICC is able to take some action and to ask the terminal to take some actions in front of this call. You can have automatic answers, you can have tracking, you can use the information from this call, for example, also to drive the roaming system. So that's the two types of application in a eUICC. Then, of course, there is 3GPP. So 3GPP defines the eUICC applications in addition to the whole 3G, 4G, 5G network. But okay, what is important for us is the eUICC applications. So there are two main types of application, which are Usim and Isim. So Usim is the basic application for accessing a 3GPP network. That's the application that is doing the authentication in order to authorize the terminal to connect to the network. Okay, and there are some APIs defined by 3GPP for these Usim, Isim applications, and also some APIs extending the toolkit APIs defined by HCSCP. For example, for what I just said about the call control, it's a 3GPP feature and it's defined in 3GPP APIs. Okay, and if you look at these specifications and all the HC and 3GPP specification, so today Java Card is the only way to support interoperable applications on a eUICC. Of course, you may have a Usim native application or any kind of application which is native, but this native application will not be interoperable. You will not be able to load this application on any eUICC in the field or any eUICC available from your supplier. The only interoperability that you will get is by using Java Card. There is no alternative today. Okay, another organization which is also dealing with Java Card is GSMA. So there are 3 different groups in GSMA that are doing something of interest for us. The first one is the Isim working group. So Isim working group defines the Isim, which is starting to be well known now and starting to be widely deployed. This is a work which was started in 2013 for M2M, for machine to machine, because for machine to machine, sometimes in some configuration, there is no way to remove a SIM card and plug a new one just because it's too costly or simply because it's not accessible. So that's why there was a need for defining remote provisioning. And now it's also available for consumer devices like smartphones, and a lot of new smartphones coming on the market today already support the eSIM. And if you look at this specification, so Java Card used to be mandatory in these specifications. This has changed for M2M starting in version 4, and this may change for consumer starting in version 3. So Java Card may become optional just because some people have the feeling that in some specific market, Java Card may not be required, interoperability may not be required. So that's why it was decided to make Java card optional. However, if you look at the operators profiles, which are today loaded on an eUICC, and Thales is one of the main provider of remote management platforms for these eSIMs, more than 90% of the profile which we are loading today on eUICCs contains at least one Java card application, and sometimes more than one Java card application. So if you want to support the MNOs and the MNOs profile, if you want to reach interoperability with the MNO profiles, then you have to support Java card, except if you target only a few % of the MNO which are not using that. Okay, there is another group which talk about this group also later in other organizations, that's Iot Safe. So Iot Safe is defining how to leverage on an hardware secure element as a root of trust to establish end-to-end security between an IoT device and the backend. The backend may be a service provider server or even a cloud server. So Iot Safe is an application in the eUICC. It's also a framework. It's a framework for security, but it's also an application running on the eUICCs that generate some keys that are used for the authentication with the backend, in the same way as a eSIM is doing that, except that it's based on TLS, so it's not specific algorithms like for 3GPP. And then the last group, which could be interested for IoT device makers, is the SAM. So SAM means secure applications for mobile. And SAM defines a way to load an application. So in that case, that will be a Java card application, because that's the only way to load an interoperable application in an area, in a secure area on an eUICC, but basically you can reuse this technology on any kind of secure element. And loading this application can be done by any third party, which is somewhere authenticated in the system. So this will allow service providers, device makers, to load their application in order to secure their business in the eUICC or in the secure element. Okay, so Iot Safe and Isim, that's mature specification. You can find the specification and you can download them from GSMA website. SAM is currently under development at the requirement level, and you should see the specification next year on that. Okay, another group which is interesting also is the TCA. So TCA is the new name of the SIM Alliance. It means Trusted Connectivity Alliance. And there is a first group, which is the eSIM working group. So you will see that TCA is working a lot in conjunction with GSMA. So the eSIM group is the equivalent of the eSIM group in GSMA. And in TCA, we are working on the definition of the format of the data which is used to download a profile on an eUICC. So this specification is defined by TCA and referenced by GSMA, and today that's the only way to load a profile. It's to follow a TCA specification. And this specification includes the installation of Java card application inside security domains as defined by Java platform. And TCA has also an Iot Safe working group, so same name as in GSMA. And in that case, even same chairman. And in TCA, Iot Safe is working on the application running on a secure element or on an eUICC in order to secure the IoT data communication. So this application is defined by TCA. Then the implementation, it's up to you, but there are some suppliers that are ready to provide Java card code for this application. So that's a library, and you just pick to your favorite supplier and put in the eUICC and integrate in your system, or even customize for your own application. Okay, then there is also some regulation and recommendation at the political level. And if you look at what happens in European community, there is an agency called ENISA, which is the agency dealing with cyber security for the European Union. That's a quite old agency established in 2004, but reinforced a lot by the Cyber Security Act, which was approved by European Union members in 2009. And ENISA is working a lot on IoT. They issue several documents, and here this is an extract of one of their documents, which is named Good Practices for Security of IoT. And you can see in their recommendation, in the chapter Development and Implementation, they are talking about libraries and say that use of trusted libraries is a good practice for securing the IoT, especially when these libraries are tested or certified with some security criteria. And then they recommend also to use external check. This means that these libraries, all the tools, the APIs you use during your development shall be proven secure and updated by a third party. So proven means testing, means certification, and okay, secure and updated. We'll look at the importance of updates later. In another chapter dealing with testing and acceptance, they once again emphasize the role of security requirements test. So you have to perform security tests, not only functional tests, but security tests. That's something you can use external lab to do that. They will test your software for security in order to try to detect vulnerabilities. And also doing some penetration tests. So penetration test is what is done today on every secure solution. So there is a well-known list of attacks today used by different people, and you have to test your device, your software against all these known way of attacking a secure system. And this penetration test is usually performed by some labs who are specialized in penetration test. It's referred sometimes if you can have a pen test. So pen test means penetration test, and it's if you work for security, you will hear that word a lot of time. Okay, certification. Certification is something very important. So if you look at the number of devices, so that's some figures I collected, I think, on the European Commission website, you see the forecasted number of IoT devices, of connected IoT devices. So we already have a large number in 2020, and you see that it will more than double during the next 5 years. So the more devices you have on the field, the more important is security. Because if a few devices are at a risk, okay, that could be okay. But when that's billions of devices, which are at a risk, then security, safety, and privacy start to be a very big issue. So when you think about your development, you have to think about scalability and the fact that, okay, there are a lot of devices, so the requirement for security due to this very large number of devices will increase and needs to be addressed. When you have billions of devices and these devices can be compromised and generate attacks on networks, denial of service, or subject to hijacking and to be transformed into a bot on the network, then that's a very big issue. That's why I'm pretty sure that more and more countries or organizations will require certification, which is the best way to ensure that devices are secure. Okay, however, certification is something costly, especially if you don't know how to do that. And if you want to certify your whole device from the hardware up to the last line of software, that's probably something that will take time, probably too long for your time to market target. And also the cost will be too important for in order to recover this cost on the cost of the device. That's why we're using already certified platforms and application is probably a good idea to remove the overall cost of your development and the overall cost of operating your devices. Okay, then we'll have a look at some use cases for Java card applications. And I selected two use cases. The first one, that's roaming management. Today, when I was talking earlier about more than 90% of the profiles coming with Java card application, I would say that probably 99% of these applications are roaming management applications. So why that? Just because roaming cost is under pressure. Because, for example, in Europe, you are no more able to charge for roaming inside Europe. But roaming, it's an agreement between different MNOs in different countries. And that's probably a good idea for these MNOs to be sure that that they will balance the roaming between them in order to okay, I supply roaming to this MNO customer, then the other MNO will provide, or I will provide roaming for the other MNO's customers. So if you can balance that, this means that the cost will be nothing for everyone. But when it comes unbalanced, you probably have one MNO asking money to the other one. And at the end, you know that when an MNO has to pay for something, that the end user that will have to pay for something. That's why roaming management is important. So there is today some network solutions in order to manage roaming, which are able to achieve up to 75% efficiency. However, this is not enough. This is 1/4 of the devices on the field that are not under control. And if you combine these network solutions together with remote management, so over-the-air management of the Isim application and the Java card application loaded inside the SIM, then you can achieve more than 95% of roaming traffic onto the most suitable network. So you can really drive the device to connect to the network, which will fit with your roaming agreements. Okay, so roaming is not limited to smartphone. Of course, today that's the main issue because smartphones are the device which are traveling the most, but IoT devices also are subject to roaming. Smartwatch, cars, that's the kind of device which are traveling and that could cross the borders. So even for this kind of devices, you need to be able to handle roaming applications. So you need to support Java card to handle these roaming applications provided by the MNOs. And there is no standard application for that. Every MNO has its own application and its own way to manage roaming. So if you don't support this application, then at the end, okay, the cost may be supported by the end user because an MNO will accept this kind of device on their network only with additional fees, or they will have to pay for roaming because the MNO will not be able to drive this roaming correctly. So that's additional cost at the end for the device and for the end user. Okay, and so I would say that today, once you have a 3GPP device, it's mandatory to be able to support this roaming applet in order to be accepted by the MNOs. Okay, another application I think which, especially in this context of IoT, is important is securing the IoT. So I already talked about Iot Safe. Iot Safe defined by GSMA and by TCA. So basically, if you have a 3GPP device, the 3GPP device, all the 3GPP device comes with eUICC because it's mandatory in the 3GPP specification. So it comes with a eUICC with a Usim application, but there is probably some room in this eUICC in order to load an application that can be used for securing the IoT, especially in the eUICC. This application can be loaded by a third party or can be loaded by the device maker. So basically, it comes for free. It comes for free as long as you use a standard for this application, like Java card, in order to load this application on the eUICC. Okay, and securing the IoT, it's not limited to securing the communication, but it's also securing the device. So you can use your own application in order to secure the device also. And if you look at some also in this recommendation, they issued a guideline for securing the Internet of Things. That's a very new recommendation. See, it was issued last week. They say that the full life cycle of the device shall be secured from design to refurbishment. So it's not only communication. Security is a wall. It starts from the design, it goes to the end of life of the device. For example, when you don't want anymore to use a device, you need a secure way to erase all the data. That's part of the security. Otherwise, your privacy is at risk. And also this old device, if there are no proper ways to erase some secrets, this old device can be used to retrieve some keys. So someone can retrieve some keys just by collecting devices in the trash bin, for example. So you need a way also to secure these devices that are no more in use. And they recommend to use a technology which is called security by design. So security by design means basically that you have to think about security from the beginning of the design of your product, not only at the end. Okay, then we'll have a look at different stuff, different requirements, and different trends today on the market. So first of all, I would like to say that the use of secure elements is not limited to devices using 3GPP connectivity. So we have seen that for a device using 3GPP, basically you have a secure element. You have a eUICC, so you can use this eUICC. However, there are a whole bunch of IoT devices not using 3GPP connectivity, using Bluetooth, using Wi-Fi, which need to be secured. Because that could be devices controlling your home, controlling your secure access to your home, controlling your healthcare, controlling your privacy. If you have a device collecting some health information on yourself, you want to protect your privacy and you don't want these informations to be available for everyone. You can think also about a pacemaker. A pacemaker today is a connected device. And it's very important to secure this kind of device because basically if you can hack this device, you can remotely kill someone. So security is very important. I think I've seen in the past some publication about people hacking pacemakers, which makes me very afraid. I would not like to have this kind of device in my body. So securing these devices is not an option. And today, the best way to secure a device is to rely on a secure element as a root of trust. And as shown, if you use a secure element embedding JavaCard technology, you can reuse certified components, both hardware and software components. You can easily customize this device by addition of JavaCard application on top of all the service already provided by the secure elements. Meaning that for this customization, the only effort you will have to do will be to properly test or even certify your small application. And then the whole system will be secured because you have a certification by composition if your platform is secure and if your platform provide good isolation between the different applications, like JavaCard is providing, then your whole system will be secured and certified. There is also the diversification issue. A connected device or any kind of device, you need diversification for having a unique ID in the device. So that's something today which can be easily managed by any hardware component. But you need also to diversify some keys. In that case, for the keys, you need a connection between the device that will generate the key and some backend, and you need secure connection. You need to do that in a secure way, and that's something that secure element is doing, and secure element provider are doing every day. We are personalizing millions of secure elements every day with different keys inside different secure elements. It's keys, it can be also pin code. You see that today the main vulnerability of IoT devices is the pin code or password, which are all the same in all the devices. So that this means that these devices are very easily hacked because basically people never change the password. And this secure element can be used as a root of trust for the whole system. So you will build security starting from this secure element. And also security implies updatability. A device may be secure the day you issue it, you put it on the field, but 1 year later, there will be new vulnerabilities because, okay, the attackers are evolving, find new ways to attack your device. Technology is also evolving. Cryptography will discover some flaws inside cryptographic algorithms. So you need to be able to update these devices. There is also a simple way to update the device, is simply to replace it. But sometimes, okay, that could be easy with a SIM card, which costs only some cents. But for a more complex device, that's probably not something you want to announce to your end user, that he has to pay for a new device to get it secured. Okay, there is another technology which is also coming. You may have heard about that. That's integrated secure element. It could be integrated eUICC. It's sometimes named Isim also. So integrated secure element technology has the potential to reduce the cost. So it could be very interesting for IoT devices. We also have a better integration, so making smaller devices less power consuming and so on. The security target of this integrated technology shall be equivalent to what we provide today with embedded secure elements. However, that's a new technology, so this is still to be proven, and it comes with new issues and new difficulties when using that. So first of all, customization. Customizing a secure element, that's one simple microprocessor, simple operating system. That's something you can do easily. When you talk with a system on chip, that's very complex system with very secrets, secure and security measures inside that may be difficult to access except by reusing what is provided by the system on chip provider. So this means that development on the system on chip will be harder than on a secure element. Diversification. So diversification is the fact that you put different keys in different devices. It will be also more complex because system on chip are very limited in terms of internal non-volatile memory. And basically, you can probably store one or two keys that will be used to secure the device, but you will not be able to store the keys that you use in your business. Because these keys will be stored in an external memory. So the external memory is secured. But this means that only when your device is assembled, so when you connect your system on chip with this external memory, only at that time you are able to make the personalization and diversification of the device. And okay, we know that most of the devices are today manufactured in remote location, in low-cost factories that are not secured or are not as secured as the production site and personalization sites used for secure element are secured. And in addition, you need a connection between the device and the backend when you generate the keys in order to be able to have the keys in the device, but also in the backend so they can communicate together. And also, when using system on chip, the secure element is not the only stuff to consider during the security evaluation, because you will connect the system on chip to an external memory. This external memory has also to be secured, so you can easily use cryptography to protect the content. But there is something very important in secure element, that mechanisms in order to avoid replay attack. For example, if this external memory can be saved and restored every time you try a new PIN code or a new password, on the system, then you can easily understand that you can try all the pin codes, all the password you want, and every time recover the previous memory so that you can indefinitely try in order to make some tries in order to find the pin code of the password. So this is not a secured system. Okay, customization. So IoT devices are today distributed through various channels, and these different channels require branding, require customizations. So for example, the MNOs, they are providing a lot of IoT devices in their shop. And every time they will require some customization. So not only branding, but also customization in the way these devices will connect to the network, will connect to the back end, because the MNO wants to offer the services also in the back end. Different service providers may use different protocols, different way to exchange the data. And customization may not be limited to the data, but also to the algorithms. And for example, different countries have different regulations in terms of cryptography. If you go to China, you have to use Chinese algorithm. If you go to the US, you have to use algorithm which are certified by FIPS. If you go to Europe, that will probably be also different algorithms. So that's the algorithm, that the key length, privacy regulation may be different. So you will need also to customize your devices depending on the different countries. So at the end, you may have multiple versions of your software. Multiple versions means multiple tests, multiple certification if you deal with security. So using a technology like Java Card, which is very modular, that's an object programming language, that will allow you to perform this customization without harming the security of the whole system, because that's only one small piece of software on the top of the big system that will be customized. And thanks to the isolation provided by Java Card, you can be sure that this customization will not harm the security of the system. So that's something important to consider. Okay, then last thing is the software update. There is no security is a moving target. When you design something, when you certify a device, so the lab who will certify your device, they will give you the insurance that they have tested all the known methods of attack, all the known vulnerabilities, and that your device is secure against these known attacks and vulnerabilities. But you know that things are moving and new vulnerabilities are discovered every day or every year. New types of attacks are emerging. If you remember a few years ago, people started to look at the power consumption of a device in order to recover some keys. So that's these new types of attack are coming every day. So even certified products may suffer some security issues. That's why you need a way to update these devices in order to correct these security issues. And that's really regular update is mandatory in order to maintain the security of the device. And thanks to Java Card modularity, thanks to global platform architecture, global platform protocol, that will help you to manage and to deploy these updates. And for example, with Java Card, you can update only one small part of the software, where only one object, one piece of software that will easily connect with the rest of the software. With a traditional operating system, usually you have to update the full operating system. It's not easy to patch. So by reducing the bandwidth needed in order to deploy this small patch rather than the full operating system, you will also save some money. And you will reduce the time for deployment of these updates. Okay, so let's go to the conclusion. So what I wanted to say today that when you deal about IoT, when you define an IoT solution, you have to think about security and privacy from the beginning, and that should be something you have in mind every day during your the specification and development of your product. IoT, so small devices, may not be a mass market like smartphones. That's low-cost devices, so difficult to recover the cost of heavy certification, heavy test. So by assembly pieces of technologies that are already proven, already certified, will probably be more efficient than developing everything from scratch. And you also need to think about customization from the beginning. How my device will be able to be customized in order to reach the requirement of different markets or different vendors of this device. So if you take into account security, privacy from the beginning of the device, and you have to look at the total cost. So not only the cost of the device, but also the cost of the development, the cost of the maintenance of the device, the cost of the customization of the device. So think about, okay, should I develop everything from scratch, or try to reuse as much as possible technologies that are available and that are proven? How do I manage certification? Can I rely on parts which are already certified rather than doing a full certification of my device? How will I manage the deployment of the updates? Because you will need to update your device. And how do I manage customization of the device? And if you look at all these points, at the end, you may realize that Java card, using Java card will probably be cheaper and more efficient in order to reach the goals you have for your product. So you really need to think security from the beginning and to have all these elements in your mind when defining your product. Okay, that's all that I wanted to say today. So at the end, I would like to thank you for attending this webinar. So this presentation will be available on the JavaCard Forum website, I think on the page where you register for this webinar. The PDF will be available, I think, very soon, and you can always contact me on my email. So I did this webinar also this morning, and I already received some questions and some comments. So I will be happy to answer to that. Anyway, we still have a few minutes for questions. So I think now you can open the mic. So if you want to ask a question, you can. Okay, I'm back. Sorry, I was muted. Yeah, so you can ask your question directly, but please unmute yourself, or you can ask the question in the chat. Okay, so I give the floor back to Jean-Daniel for managing this part.
Thank you, Denis. So, any questions? Please just unmute your mic and go away. Go on.
So I think there are some questions on the chat window.
There are some questions, but yeah. Werner?
Jacques Lato here. I have a question. You can hear me?
Okay, please. Yes.
Yeah.
So the question was around roaming. I'm not an expert on roaming, but how would be sending a profile to a Java card that is on a different MNO? Like, what are the cost implications of that?
So roaming applets work that way. So the applet is supplied by the MNO. The applet is customized depending on the requirement for the MNO, on the different business agreements this MNO have with other MNOs. And basically what this applet is doing is that when you go abroad, when you connect to a foreign network, this applet is aware of that. It gets some events coming from the terminal signaling that, okay, you are connected to another network. Then this applet will be able to communicate with your home network, with your home MNOs, in order to get some instructions. So what should the terminal do when connected to this network? Is it okay, or should I move to another preferred MNO? And depending on the country, you will receive some updates of some files called PLMN files, or preferred network files, that will be used by the terminal to connect to the best network for roaming. So you have a preferred network file. You have also a forbidden network, list of forbidden networks, and that is used by the terminal. And these files are located in the Usim applications.
Thank you. Time for another question.
In your last slide, in your conclusion, you mentioned that the IoT market is a small market. Is this really true?
I'm just saying that IoT market, okay, that's low-cost devices. That's okay, a few tens of euro compared to the cost of a smartphone, for example. So this means that the size in terms of revenue of this market is smaller than the size in terms of cost of the smartphone market. This means that you cannot afford very costly and complex test and certification. That's why reusing existing technology is probably a good idea. And you also have to be very agile in order to update your product, to customize your product.
Okay, it's not the number of devices, it's only the revenue you can achieve in this market.
Yeah, yes. but also the number today. If you look at the figures of potentially connected device, I don't know how it compares with the number of smartphones, but it's probably less than the number of smartphones we have today. Of course, this will change, but okay, today the smartphones they are not thousands of different smartphones available on the market today, but in the future you may have thousands of different IoT devices. So this means that for each device the market may be smaller, also in number of devices.
Okay, thanks.
We have about 6 questions from Hannes Scheffening. We don't have time to address all of them, but Hannes, is there one in particular you would like to have an answer now?
You can hear me. Yeah, we are running out a little bit of time. I was wondering, out of these questions, I was wondering of what is needed for a third-party provider to push an app to via the SAM to the device. Like you said, like it sounded like it would be trivial, but I think there is more to that, right?
Oh, you're not on it. I'll reply on your behalf.
Oh. Okay, so SAM today is under development. So we'll have a good view on what is SAM probably next year. But the idea is to use a similar technique.
I'll respond for you, and then you can go.
Oh,
I guess you're not on the email. I don't know. He just responded to some whatever one.
You're on, Natasha. You're mute. Please.
yeah. Okay. So the idea of SAM is to reuse the technology used today for Isim. So you will go through a server. It could be your own server as long as it is trusted in the ecosystem, and you will be able to reach any SAM-enabled secure elements using the proper security mechanism. And the way you will load application, you will probably reuse what is defined by TCA, the profile package specification, because basically that's an application can be deployed using the profile package specification. Everything is there and is ready. We may need some adaptation for secure elements, but for eUICC, that's something ready.
Okay, thank you, Danny. So it's a little bit past 6. Thank you all for your attendance. We will send you the PowerPoint and keep tuned so that you can attend the 4 remaining webinars in the coming weeks. Thank you, everyone, and good evening or good morning, depending on your time zone.
Thank you. Goodbye.